All right, guys, we're going to go ahead and jump into the CFA and going through the answers and our thinking on CFA 7, 9, 10, and 11 here. So again, complete the paper copy and listen to the reteaching here, and we'll talk about any questions you may have afterward. Okay, so we've got an XY chart here where we're trying to find what's the rule between the number of pints of milk and the number of quarts of milk here. So we're going to start breaking this down, and one of the strategies we talked about was trying to see when this goes up by 1, when the x goes up by 1, what happens to the y. We also can look going across here from x to the y, and I can try and see some things here, and I do see a pattern here. I do see that it's cutting in half. So if I cut 4 in half, you get 2. You cut 1 in half, you get 0.5 or a half. So another way we talked about, sometimes it's not so easy to see some of those things, but when this one goes up by 1, what's happening over here on the y? And I see that goes up by 0.5 or a half. Again, this goes up by 1. So my thinking is, so far, does this go up by 0.5? And if it does, that would go to 1. And I kind of see the pattern continue when this one goes up by 1. This one, let's see if it goes up by 1 or another 0.5, excuse me. Another half, and I get 1.5, and then I see that it works because I go up 1 here and go up another half here, and 1.5 goes to 2. So I see that pattern is working. And we know when this is adding a half every time, we've learned that what I'm doing then is taking a half of x every time. Okay, so before we start doing that here, let's finish the chart. If I'm cutting it in half going from the x to the y, then I double it going from the y to the x. So this 7 doubled would be 14. And again, I cut 14 in half, I get 7, and I see that pattern continues and works. So describe the rules in words. What we're basically doing is we're cutting the pints in half to equal the quarts. So pints cut in half will equal the quarts. Okay, or the x cut in half will equal the y. Okay, you can look at it either way, but in this case we're comparing pints and quarts. And so we figured out in the equation, when this one goes up 1, this one goes up a half, that means it's a half times each x. So I could say a half of x equals y. Okay, and some people might write x divided by 2. You could write that as well. Will equal y. Dividing by 2 is the same as multiplying by a half. But again, the rule we try to get is if this is going up the same every time, that's what I'm multiplying the x by. And in this case, it's a half. So to write the ordered, the numbers in the table as ordered pairs, I'd have 0.00, 1, coordinate 1, 0.5, coordinate 2, 1. Again, making sure you're writing all these in. Coordinate 3, 1.5. Coordinate 4, 2. And then point 14, 7. So I have many points, and we're going to go ahead and graph this relationship between the number of pints and the number of quarts. So make sure you have these written down. I've got them written down somewhere else. We're going to scroll down here and graph this situation and see what it looks like. Going to be linear, going to be a line here. So we'll take a look at that in a second. So make sure you have all this written. Pause the video if you need to make sure you have all of this stuff written down. All right, so we're going to go ahead and scroll up here, and we've got our graph. And on our graph here, we're comparing the pints of milk compared to the quarts of milk. Remember, the pints were the x, so we've got that on the x-axis, and the quarts was on the y-axis. So 0.00 was one of my points that we had. 0.1 and 0.5, so over 1, up a half. Another coordinate there that you have written above is 0.21, over 2, 1. And you can see the pattern there going. Over 3, up 1.5. Notice these go up by halves. Okay, so got to see how they've got the number lines labeled there. Over 4, 2, and then over 14 and 7. So 14 and up 7. And you'll see that this forms that straight line. I wouldn't have to graph all those points. When I get 3 or 4 of them graphed there, you can see, we see the pattern. I can just connect that. Again, it would keep going all the way through there. And again, I could line that up and finish, but we know that pattern would continue. And that is the situation. Whenever this one goes up 1 on the X, it goes up a half on the Y. So we see the graphed relationship between pints and quarts. Okay, so again, make sure you've got this graphed, and your expectation is you should be able to graph the relationships between different situations. In this case, it's quarts of milk compared to pints of milk. So again, making sure you've got this stuff here copied down, and we'll flip the page and get to the second part here in a second. Alright, so on this graph we're looking at train travel, and we're going to study the graph this time and be able to read this. Okay, and we're comparing the time down here on the X to the distance miles that this train travels. Okay, so I can do some things just reading here. I can go over and say 1 hour. I know it goes, let's see what they're going by. It looks like 20s, 20, 40, 60, 80, 100. So I can label 20, 40, 60, 80. And I'd probably go ahead and label so you have most of these going up by 20s. So I can easily look over here and I can say in 5 hours they'd go 300 miles. Okay, so I can easily see that it's going 60 miles per every 1 hour. I can just look at that 1 hour. There's my unit rate. We're going 60 miles every hour. Okay, so if I put this in an XY chart, which sometimes helps us find the equation, I could easily say in 1 hour it goes 60 miles, so I can look at this relationship. In 2 hours, 120. 3 hours, 180. 4 hours, 240. And then we already said in 5 hours they go 300 miles. So I can use this to help me find the pattern if I'd like to. Again, we've talked about if this one goes up 1, this one goes up 60. So we're trying to see how much they go up. This one goes up 1, this one goes up 60. And that pattern continues. And we know that then every hour you go 60 miles. So when we look at that, the equation they could use to find the distance, it could be, and I'm going to write up above here so I don't have to change my linings here, but I would write 60 times X times the hours will always get me my Y, or my distance traveled. So this would be the answer for question A. 60 times X, again, I see every time this goes up 1, this goes up 60. I can also see here I'm going times 60, times 60, every single time to get it to 180. Again, if I couldn't see that pattern, I could just divide 180 divided by 3 is 60. 120 divided by 2 is 60. And you see that constant rate there, and you can see that every hour they go 60 miles. Okay, so there'd be our equation for that. Now it says use the graph on part B, and you can't see it there, but on yours it says use the graph to calculate how far the train travels in 2.5 miles. So I'll go ahead and move it up here. Okay, how far it travels in 2.5 miles. And I'll move this out of the way. You should already have this copied here. 60x equals y for part A. It gets my labels off a little bit here, but we can still get it figured out. How far it goes in 2.5 hours. So I'm going to use the graph. So I'm just going to go over 2.5 hours, which should be right here. And I'm going to follow it up and see how far I've traveled in 2.5 hours. So I can follow it all the way up. Okay, and look right in here. And I can see right where it connects. Okay, in 2.5 hours, I can see right there that it's going to go 150 miles. Because this is 120, again I'll relabel, 140, 160, 180. And if I look right here, we're halfway between 160 and 140, which would be 150. So in 2.5 hours, we're going 150 miles. I also could use my equation that I had of 60x equals y, and I could plug it in and take 60 times 2.5, and that will equal my y. And if you take 60 times 2.5, okay, you're going to get the y to equal 150 if you do the math there. So again, I can plug it into the formula once I figured it out, or I can just use the graph to go over 2.5 hours and track up and see how many miles we've gone then. Okay, so again, to explain how you did that, you can write your own explanation here, but you can substitute it into the formula, or you can use the graph. Either way to help you find that. Okay, so I'm going to scroll down here a little bit again. Pause the video if you need to. Get this information written down and different ways to think about it and read this graph and come up with the equation for the situation and the relationship between time and distance in this case. All right, in the last part down here, we've got these weird looking graphs here, and our job is to try to select one of these and give a situation that can be represented by these graphs. You could have picked any one you would like here. I'm just going to give a situation for each. Okay, so graph A. There are lots of different things this could be. In one situation, could this be the height of your grass in the spring? And the reason I say that and come up with that is because the grass is growing at a rate and then you mow it. It grows at that same rate, then you mow it down. You could be thinking, something like that. Some people could say, could it be a haircut where your hair grows to a certain length, you get it cut again? So there's different situations that could represent. Okay. This one, on this graph I read, it's constantly going up here at a decent rate here. Could this be, for example, the height of a person from, I can pick some ages, like age 4 to 10, for example. Could that be their height? Okay, when their age goes up, their height goes up. So your age could be down here and the height starts going up at a different rate there when they're growing from, say, maybe age 4 to 10. I could have picked maybe any ages there, but as you get older, that would taper off and that graph would start to look different when you don't grow as quickly. Okay. Question C, we see we're kind of below here, so I think temperature a lot of times on this, or I could think also another thing I could think would also maybe be like if you plant something under the ground. Okay, so the height of a plant could be height of a plant starting with the seed, maybe. Because you'd put that seed underground there again, and it would start growing and eventually start to get taller as it grew with sunlight and water. That could be a possibility. And then graph D, again, I see it also starts below. So again, I sometimes will think temperature. Could it be temperature on a day in Iowa? Let's just say in February. Okay, the picture, and again, the picture, it starts maybe below 0 because it's February, so it's cold. And as the day goes, it gets a little warmer, and then it gets into night again, and it starts to cool again and may get back to exactly freezing if this was my freeze line. So again, different ways to think about these. There's lots of different answers you could have, but there are just a few to be thinking about what those graphs could possibly represent. Again, make sure you've got these things all written down, and you'll see all these things on your upcoming test.